All right, good morning. I'm planning on doing the Leetcode bi-weekly contest from this morning. Bi-weekly contest 74. Alrighty, so here we go. Open these guys up. All right, divide the array into equal pairs. You're given an integer array nums consisting of 2 Boolean integers. You need to divide nums into n pairs such that each element belongs to exactly one pair and the element pairs are equal. Okay, so there needs to be an even count of each, right? So let's do this 10:50 a.m. All right, and then we'll use a map to count each value in the array. Let x of a, m.set x1 plus, m.get x or 0, return m.every count is evenly divisible by 2. All right, do this guy. Looks good. Here we go, 10:50 a.m., 10:51, oops, 10:51 a.m. About 1 minute, right? Nothing too fancy. Okay, so let's do the same for Kotlin, Python 3, JavaScript, or XNA. RM equals mutable map of int. All right, let's do this. M sub x equals 1 plus m sub x. Elvis operator 0. And return m dot all count. Oops. Count modulus 2 equals 0. Looks good. Okay, so Kotlin, JavaScript, do Python 3 for XNA. It's our map. Actually, this would be just a counter. Or actually, we just make this a default dict. That should work. Right, default dict integer m sub x equals 1. Return all count in m or so count modulus 2 equals 0. Go. Cannot unpack non-iterable object. M dot items. Looks good. Okay. Do this in C++. Oop. Print. Using map will be our counter. All right. Okay, and then we'll do this in Rust after this, and then move on to question 2. So x. Return m dot size equals count if m dot begin, m dot end. Pair, destructure the pair, auto x I don't care about. Pair, return count modulus 2 equals 0. Looks good. What is this? Thing I get stuck? Okay, I mean, that looks good. Submit. Accepted. Actually, I'll do this. Return all of, I think. Is that? Yeah, okay, that looks good. It's a little bit better solution. Okay. And let's do this in Rust, and then we'll stick it in the discussion board after that. CI equals spec I32. CI, then use std collections hash map. Let mute m equals hash map new for x and a. The arbitrary location of m.entry sub x in or insert 0 equals 1. Then for each count in m, if count and 1, turn false. Yeah, I'm not sure how to do this functionally in Rust, so do it the long way. Let's do this count modulus 2 is equal to 0. Or does not equal to 0. Hold on, this is backwards. Okay. That looks good. And I wonder if we can iterate through this. Let's see, return m dot wonder if there's an all in Rust all of. All of predicate. Any iterator, any all Rust iter all any all. Yeah, that's what I want. All. I think all. Let's just try this. Don't really know what I'm doing here in Rust, but I'll give it a shot. M dot all. Oops, hold on. X count modulus 2 equals 0. Let's comment that out. Let's see what happens. Expected 1 of 7 possible tokens. And oh, not this, it's that. No, oh, I need iter, right? M dot into iter dot all. Closure is expected to take a single tuple as an argument, but it takes 2 distinct arguments. It takes 2 distinct arguments. A tuple. Can I destructure it like this? Yay, okay. All right, cool. All right, so there's Rust. Let's stick this on the discussion board. Nothing too fancy, just a map of counts, and then make sure every count is evenly divisible by 2. Return true. Let's see. Use map m to count the frequency of each value x of the input array A, and return true if and only if all frequencies are even. Kotlin, JavaScript, oops, Python 3, Rust, C++. All right, let's copy and paste these in here and then get on to the next question. Rust, C++, Python 3, JavaScript, Kotlin. All right, a few solutions, post that, and let's move on. Q1 down, Q2 will start at 11:01 a.m. Okay, here we go. Maximum number of subsequences in a string. You're given a zeroed index string text, another zero index string pattern of length 2, both of which consist of only lowercase English letters. You can either add patterns from 0, patterns from 1, anywhere in text exactly once. Note the character can be added even at the beginning or end of the text. Return the maximum number of times pattern can occur as subsequence of the modified text. A subsequent string to derive another string, deleting some or no characters without changing the order of the main characters. Okay. If we add pattern 0, which is character A, in between texts of 0, 1, and 2, we get ABA, right? Okay. The number of times AC occurs as the subsequence is 4. Some other strings have 4 subsequences AC after adding a character to text are there and there. However, those strings such as only have 3 subsequences. Okay. Okay, so it makes sense to add the first character to the left and the second character to the right. I don't know. I don't get it, I guess. Right, and then you use the rule product. This. Okay, game plan. Place pattern sub 0 onto the left of text. Place pattern sub 1 onto the right of text. Count number of patterns sub 0 before each pattern sub 1 and use rule of product to accumulate each product from indices ij, which can be where, right, where text sub I is equal to pattern 0 and text sub j is equal to pattern sub 1. Does that work? Right, stick that over there, stick that there. Right, we never want to do anything other than that, right? That's the optimal solution. Stick the A way over here. Stick the C way over here, isn't it? There's a subsequence. There's another A here. Hold on, let me play with the text a little bit because I think this does matter. Right, 0, 2, 3, 4, 5, 6, 7, 7, and then we stick the C here, we stick the A there. And we have the count of A is 1, 2. Count of C is 1, 2, 3. So how many subsequences can we make for each A? Right, there's 2 A's and there's 3 C's basically, right? So 2 A's, 3 C's. So we take the minimum of those, like 2 and 3 equals 2. And then multiply that by itself. Right, minimum 2 and 3 times minimum 2 and 3, 2 times 2. And then the other one would be 3 times 3. I guess so. All right, so let's just do this and let's just assume that we've already added the pattern first character onto the left and the other to the right. So we have ij, right? I goes to the right, j goes this way to the left as we process, right? Count text of I equal pattern, pattern sub 0. Text of j equals pattern sub 1. Right, A equals that and B equals that, right? And then we're return min AB squared. Okay, so let's implement this and see what happens. Maybe I'm wrong, I don't know. Better to fail sooner than later, though, I suppose. Let's see. Let's do this. Text string. N is string's length. I is 0. J is n minus 1. While I is less than j. I wonder, I have a doubt maybe. What if I had A, C, 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 but then I had another AC at the end? Right, that's not a correct algorithm then in this case, because that's one additional. That should be, how is it that we're counting substrings or subsequence? Maximum number of times pattern. Some of the 6 are those. For each A, how many B's are there? For each A, how many B's are there to the right? Right, that's what I want, okay. Okay, not quite that naive of an algorithm, right? Algorithm, but close. So for each S sub I, which equals pattern 0, count plus equals the quantity of pattern sub 1 to the right of I. Right? Okay, that makes sense. Okay, so what we can do is pre-processing. So pre-process the input string s from right to left. Go this way. Right, so we keep a running total of the quantity of patterns of 1 at each index I inclusive. Right, okay, that makes sense. Alrighty, let's do this. The length of the string, or let j equals n minus 1, 0 less than equal to j, so it's minus minus j. And then the quantity will be stored in an array. Let's do this. Count will be our answer that we'll return at the end. Oops, return count at the end. And then I want an array of matches to the right. We'll call this R equals array sub n fill 1. Right, so we're going to assume that we're pushing B onto the right. And we'll initialize the count, actually. I want to initialize the count to quantity of B to the right, or 0. Do this, make room for the base case. If S sub j is equal to B, then count, oh wait, on R sub j equals 1 plus R sub j plus 1. Turn this into an integer. So we'll increment 1 whenever there's a match of B down to that, and then go from like 0 to n. If S sub I is equal to A, then we'll add on to the count. Count plus equals R sub I. Okay, I think that works. Let's see what happens. 6, oh, that's too many. Here we'll add on 1, 2. Sequence. Okay, so you consume it 1 to 1, I guess, then, right? Consume it 1 to 1. Okay, so plus equals 1 as long as there's 1 over there. I think I confused myself. Okay, so I'm counting too many. I need to count how many A's there have been, as well as how many C's there have been. So as long as the count of A is less than or equal to the count of C, then we plus 1, right? L Okay, so left will be the count of A, right? So hold on. L sub I is count of A and S. From left to right. R sub I equals count of B and S from right to left. So if L sub I is less than or equal to R sub I, and S sub I is equal to A, then we'll increment the count by 1, right? That sound right? And then left to right is the running total from left to right. And we'll assume that starts off with 1 as well. Plus 2. J plus 1 is less than N. Otherwise 0. R sub J, add 1 onto the one to the right of it. Same thing from L. For let I equals 0, I is less than I. Hold on. L sub I equals increment by 1, and S sub I is equal to A. Plus 0 is less than or equal to I minus 1. L sub I minus 1, otherwise 0. Okay, and count to 0. If S sub I equals A and L sub I is less than or equal to R sub I, because the count by 1. Okay, let's see what happens here. Uh-oh. It's only 1. It should be 4. What the heck? What's going on? Let's print this out and see what's going on. Left and right. Okay, so what do we got here? Bunch of 1s. Doesn't look right, does it? This is left. How many values A? Oh, it's plus equals, plus equals, plus equals. Well, that's still not right. 9? What? No, that's not right. No, it's not right. Plus equals not right. One plus, set these initially to 1 and stick these to 0. So equals that. Okay, so the count, so yeah, that's 2. The count from this side is 2, 2, 2, 2, and then 3 here. I feel like I should comment these. Okay, let's do this. Let's make life easier on ourselves, and let's do this. S equals A appended onto S, appended B at the end. There's the length of that thing. That. Set to 1. Okay, and then add them all up. 2. Okay, let's go through this and debug and figure out what's going on. This is left, this is right. Right, left, this guy. Right is this guy, and our string is this guy appended with the A over here and a C over there. That's right. 1, 2, 3. Yeah, that's right. Okay. So when it S of I equals A plus 1. How am I counting these subsequences? This guy goes with 1. I'm totally confusing myself now. This is silly. Maybe I don't understand the problem statement because, like, why is this 4? Exactly once. I guess I don't understand. Why is this not more than 4? Because you could have A with C, A with C, A with C. So that's 3. And I think this would be 6, isn't it? Oh, I can only delete characters then. Oh, I see. Okay. We're looking just for the optimal pivot index then in that case. All right, so let's do this. Best. Return the best count. Okay, so math.min, L sub I, R sub I. Let's do this. Music. Hold on one sec, get my Pandora going. Okay. Okay, so let candidate equal the minimum. Oops, what am I doing? Let candidate equal the minimum. Let low this guy, L sub I, R sub I, low times low. Let's see, best equals maximum best candidate. Okay, that looks right. And then the other one should be 6. Ah, no, 9. Okay, so it's not right. But it should be something like this, I suppose. Okay, so what am I saying here? This guy's supposed to be 6, but I'm saying it's 9. Okay, I think I'm probably gonna get ready to move on to the next question because this one is kind of stuck in A, B, B, B. And the pattern is A, B. Result is expected to be 6. But I'm incorrectly outputting 9. So fundamentally, it could be an incorrect algorithm then, right? I don't know what I'm doing exactly here. Don't have the correct formula or thought process, but it's something like this, right? Do some basic pre-processing because n is 1e5, 100,000. We need a linear scan or linear algorithm. It doesn't make sense to sort it because we're looking for subsequences. The original order matters. Oh, either or it's one or the other, not both. I see now. Okay, so I'm adding them both. Okay. Okay, so I misread the problem statement. And I added A, B onto prefix, suffix. However, I'm only allowed to perform one of those operations. Okay, so let's just create a function that'll do all this stuff. All right, let f equals our string, and then we'll just return the best of the string output then. Let best equals 0. Return f sub tick s with the a appended to the front of it, or with the b appended to the back of it. Math maximum of this guy and that guy. All right. Okie dokie. Uh-oh. Right paren. Okay, that looks good. Ah, there, it's only 4. What? How is that possible? It's not 6. Come on, it should be 2 times 3. Isn't it? Here, I'll get rid of this one. 2 times 3. 2 times 3. Oh, wait, I'm taking the minimum. Okay, so I don't want the minimum. I want just the candidate is L sub I times R sub I, right? L sub I times R sub I. Okay, that looks good. All right, use the sample test cases. All right, that's legit. remove my debug prints. Oh no, wrong answer. My output was 4, but I expect 5. Oh crap. Okay, so that's obviously saying the rule product is totally incorrect, right? Ah, man. I see. Incorrect solution. Even after I reread the problem statement and only included A XOR B onto string S. Okay, so the heck. Okay, M, where's the M's? 8, there's one M. 8. 6. 8, 6. 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 2, 3, 4, 5, 6, 7, 10, 20, 38, n equals 38, pattern equals that, so A is M, B is P. Okay, then where are the P's? One P, the P. Okay, so MP is here, right? MP, that's 1. MP, that's 2. One, 2, 3. So that's 3. So amount to M's. Well, what is the optimal solution then? I put the M to the left or the P to the right? I put the P to the right, then what would happen? I put the M to the left, what would happen? Let's see. What if I place M onto left of S? All right, so there's one more M over here. So how many MPs are there? There's 2 here, 2 here, and then 1 there. What if I place P onto the right of S? This guy, under the P over here. So there's 1, 2, 2 M's to 2 M's to the left here, 2 M's to the left here, 1 M to the left there. Okay, so I do need to do a linear scan and then count them, either from left to right or right to left, right? So this isn't quite right, multiplying them like that. So I And I should increment the count then for each of these. All right, does that work for this guy? I was having a problem with incrementing the count, and that's why I did the roll product instead. Okay, 0, 1, 2, 3, 4, 5, 6, 7 equals 7. Okay, so what if I add a onto prefix of s? All right, so 5, 6, a c c. There's two C's to the right of A, two C's to the right of A. And the other one was A, B, B, pattern A, B. I add A onto that. What if I add B onto the suffix s? I think that works either way. And hopefully I can wrap this one up because certainly it's taken a while. Okay, so that'd be C. There's 1A here, 1A there, and 1A there, so it's 3. So that one would be 4. Okay. So if s of I is equal to A, count plus equals R sub I. Okay, that looks good. That looks good. That looks good. Oh, man. Dang it. I thought I had it. Okay, another wrong solution. Well, I think I'm close. At least I'm close, I think. Hopefully. Correct solution. Again. Comment that out. Try again after we figure out what's going on. Maybe this is the corner case. Okay, so we have HH. Yeah, that does look like a corner case where H is also equal to itself, right? HH. There are no H's. Is there? HH, you need two H's. Okay. R sub I plus 1. I plus 1 is N. Is that cool? And then count this guy. So I is non-inclusive for a right lookup in case of HH. Whee! Woo! Well, that's the power of perseverance, I guess. I didn't stop. Never give up. Never surrender. And that's about halfway through the contest. So, okay, that's not too bad. I guess that was a tricky one. This one's like tricky pain in the ass, kind of. Tricky pain in the ass. All right, whatever. Right. Pre-process it left to right, right to left, and do linear scan of both candidates. All right. So is there anything else I want to do to clean this up a little bit? Well, it seems like an okay solution. It's pretty cool, right? Maybe I can stick the count here. Whatever. Okay. Looks pretty okay. And it's 11:39. So, all right, whatever. Let's just implement this real quick in the other languages and copy and paste it through here. Oh, it goes long, long. String, it's our pattern. A equals pattern. Zero, patterns one. Auto F equals, got S by reference. So our string candidate. Zero. Return our count. Okay, so the two string candidates that we want is A to the left and then B to the right. Another way of thinking about this is we just initialize the count of the character on the left to 1 plus, but yeah, okay, that makes things a little bit more complicated. Yeah, I might as well just create the key. Okay, let's do this. Auto candidate, create string and a character. Auto call it prefix, which will be a Boolean. String stream. If prefix, then string will a character followed by the string. Otherwise, it'll be the string followed by the character and return string representation of this candidate. Return maximum f sub candidate string character A as a prefix, candidate string B as a suffix. Right, and then do this. Yeah, like a vector, long, count, long. Okay. L sub n or n size n for I is 0 and L sub I equals S sub I is equal to A plus I minus 1 exceeds or is equal to 0. L sub I minus 1, otherwise 0. Okay, and then accumulate the counts for J down to 0. R sub J equals S sub J equals B plus J plus 1 is within R sub J plus 1, otherwise 0. Right, and then for I 0, I is within I. If S sub I is equal to A, count plus equals R sub I plus 1. Plus 1 is within. All right. Reference to local binding declares spec. Oh, okay. Let's do this then. Pattern 0 equals patterns 1. Prefix is a typo. FIX. No matching function for a call. Occurs single argument S, but 2 arguments are provided. Okay, so that's not quite right. Auto C, auto prefix. Wait, not right. F sub candidate. F sub candidate. Okay, that's what I want. Not viable. Expects an L value for the first. Oh, okay. Whatever. Just take it an R value reference. Okie dokie. Looks good. Okay, Python 3 is next. I wonder if I can destructure this here. If that would work or not. SAB. No, it does not like destructuring. I wonder if I can take it as a tuple. No, okay. All right, whatever. Pattern, string. Equals list pattern. I think that works. Right, yeah, that's cool. Okay. So def f string return maximum f sub s with a appended as a prefix or f sub s with b as a suffix n equals s, and return the count from this guy. Okay. L equals array of 0. R is array of zeros. N or I in range 0 until n. L sub I equals I equals A plus L sub I minus 1 if I minus 1 is less than or equal or greater than or equal to 0. Same thing from R for each J. For J in range -1 down to -1 non-inclusive by -1. R sub J is equal to the integer S sub J is equal to B plus R sub J plus 1 if J plus 1 is less than N, otherwise 0. All right, and then for I in range N, if S sub I is equal to A, then count plus equals R sub I plus 1 up to N minus 1 non-inclusive. Looks good, looks good. Yay, okay, so C++, Python 3, JavaScript, Kotlin. R, E, B equals pair, patterns 0, patterns 1, return math.max f sub s with a as a prefix, f sub s with b as a suffix, function f s string turns along, Our count equals 0 long, return n equals length. L is a long array of n, initialized to 0, same thing for R, 0, and then for I n 0 until n, if s of I is equal to A. Let's see. Else of I equals if that 1, 0 plus if I minus 1 exceeds or is equal to 0, I minus 1, otherwise 0. Do the same thing for each j minus 1 down to 0. R sub j equals if s sub j is equal to b, 1, otherwise 0 plus, let's put some parens around these things. Okay. If j plus 1 is less than n, and r sub j plus 1, otherwise 0. For I in 0 until n. And minus 2 inclusive. How about if s of I is equal to A, then count plus equals r sub I plus 1. Already. Uh-oh. Use that guy. Okay, it looks good. Looks good. All right. Let's post this on the discussion board and get to Q3. Few solutions. Try appending patterns of 0. Let's see, I guess return the maximum of 2 candidates. Patterns of 0. Let's see. First candidate would be patterns of 0 as a prefix of the input string s. Patterns of 1 as a suffix of the input string s. Return the maximum of 2 candidates, right? That makes sense. And JavaScript. On 3. Still need to do Rust. Do that next. And then C++. Okie dokie. Kotlin. JavaScript. Holy cow, yeah, it took me a while to took me a while to get to there. JavaScript. Python 3. C++. Okay, and then Rust is next. We can get Rust done here real quick and then move on to the next one. Let's A, B equal pattern 0, patterns 1. FN F S string I64. See, Rust string template literal. I think I can do this, right? Oh, format. That's right. Yeah, format. Candidate. Oh, let's do this. Last first equals format macro. Oops, hold on. Let's do this prefix. Let suffix format. Oh, that's B. Return max. Use the max. That's a prefix. That's a suffix. Okay, and then let n equal s dot length as I32 because I want to subtract from it, right? I think so. Okay, and then let count I64 0. Turn the count. Turn the count here, and then create two arrays, right? Let mute L equals vector macro, the value, the quantity are equal to the same thing, value quantity for I in 0 until n non-inclusive. L sub I equals if S sub I is equal to our target character, chars dot int equals that character 1, otherwise 0. Plus if 0 is less than or equal to I minus 1, then L sub I minus 1, otherwise 0. Do the same thing for J. N 0 to n non-inclusive dot reverse R sub J if S dot chars dot nth J is equal to C, it's 1, otherwise 0, J plus 1 is less than N, R sub J plus 1, otherwise 0, for I in 0 to N non-inclusive, if S of I is equal to character, oh, actually, prefix A, suffix B, S of I equals that character, then count plus equals R sub I plus 1, 0 to N minus 1 non-inclusive. Okay, let's see what happens here. Pattern cannot be indexed, that's right, okay. Pattern.chars.n 0. Chars dot int 1. To unwrap it or option char, right? Yeah, okay. Dot unwrap. Dot unwrap. Expected use size, okay. In, okay, cool. I don't need an I32. Expected enum option found char and dot unwrap dot unwrap can I reverse this range? Dot iter dot rev dot collect? Maybe? Nothing not found in use size. I guess I don't want to use size. I want to, let's work maybe just reverse this range. I want a range that's reversed, right? String, that's right. S sub I, S chars dot nth I dot unwrap. Count first is mutable. Index out of bounds, the length is 8, but the index, holy cow. So n minus 1 is not right then, right? This needs to be n as I32 minus 1. And what's the complaint about? Panic if converted value doesn't fit. Expected use size found I32. Use size found I32. I don't want to access I plus 1 when I'm at n minus 1, because that's n exactly. Or I can do this n plus 1. Right, that's fine. Let's just do that. It's just a 0. Index out of bounds? What the heck? Holy cow, line 11. Else I minus 1. Okay, so I is a U size. And I need to do I as I32 minus 1. Right? No. Let's do this. Println L is debug print for L. Do the same thing for R. See what's going on here. Zeros, there's lots of zeros. R in this case, it doesn't look right. rest, verse, range. Rev. Looks like I'm doing it right. Range 0 to n. Let's do this. Println prefix suffix, right? Prefix suffix. Make sure this is okay. Prefix with the A to the left, suffix to the C to the right. Why is that not being set in R then? -1. Let's do this. Let J equal n minus 1 minus I. That work? Minus 1 minus I, and then the semicolon at the end. What the hell? Expected a. Oh. Still not right, because these things aren't being populated correctly. C. How is it possible it's not? Does it need parentheses? This whole thing plus that whole thing, this whole thing, that whole thing. Still not calculating R correctly. What the hell? J. Let's print this. Print then. S of J, to J. R sub J. J. S sub. Let's do this. S sub J equals this. R sub J equals that. J, S sub J, J, R sub J. After it should be added onto. What? The index by use size, so that's right. So chars, right? Unwrap. Zero, 1, 2, 3, 4, 5, 6, 7. Okay, it's false. 0, 1, 2, 3, 4, 5, 6, 7. How is it not equal? It's not equal. Ah, okay, I see now. I see what I'm doing. A, and I need A and B. I need both A and B. Right? A, B, A, B. Oops. Okay, A, B. All right, so this one is equal to A. This one's equal to B. Then we're cool. All right, and then A. Okay, this should be all right. Okay, yeah, just get rid of this debug print. Okay, that's the good. Let's do the example test case. Should be 4 and 6. Okay, should be good. Alrighty, these guys are good. Good. Uh-oh. Prefix. Still want those down there. TLE. Okay, well, I need to process the string a little bit better, but whatever. Still got a lot of room for improvement on the rest. All right, so return the maximum of 2 candidates, pattern sub 0 as the prefix of the input string S, pattern sub 1 as the suffix of the input string S. Let's see. Form pre-process. Let's see, I guess we use L and R to pre-process the input string S by counting the frequency. I guess by counting each pattern 0 and pattern let's see, it's a by via a running total. Right, we use LNR to preprocess the input string via a running total of the count of each scene during a linear scan from left to right and from right to left correspondingly. We use LNR to preprocess the input string S via the running total of the count of each pattern sub 0 and pattern sub 1 seen during a linear scan from left to right, right to left correspondingly. Let's see. So use LNR to preprocess the input string S via running total. The count of each pattern is 0 and pattern is 1, seen during linear scan from left to right, from right to left, correspondingly to accumulate the subsequent count to be returned. That's good. Okie dokie. And we have 3 minutes left. Okay, so kind of used up all my time on the first 2 questions. They were okay questions and kind of fun. Number 2 is kind of tricky. That one really threw me off for really no good reason other than sometimes if I try to push myself faster than I'm able to go, then I end up kind of wasting my time. So that's good to know. Remember to just keep it simple, and fast is slow and slow is fast sometimes. Remember to slow down. Okay, well, I have the other 2 questions I will solve later on. So, all right, that's all she wrote. I got 3 minutes left. I'm not gonna look at Q3 or Q4 yet. I'll do those in a different session. So, catch you next time.